Good morning, this is your stat sensei, Mr. Spensei, and we're going to do a confidence interval. And here's the scenario. A company that manufactures smartphones developed a new battery that has a longer life span than that of the traditional battery. From the date of purchase of the smartphone, the distribution of lifespan of the new battery is skewed with a mean of 30. So we have a population mean equal to 30 and a standard deviation of 8. A consumer group tested a random sample of 60 and obtained a average battery life of 28 months. So a sample mean of 28. So X bar equals 28. Test the company's claim of 30 months at a 5% level. All right. Then it just says, hey, we want to actually conduct calculate a 90% confidence interval for the smartphone battery life. All right, so we're going to conduct a 90% confidence interval. The conditions, we've already conducted a hypothesis test with this. So we've already stated let mu equal true population mean battery life. We've found that it was a random sample. We checked the N is less than 10%, and we checked for normality. So we've done all the conditions part, but instead of running a hypothesis test, we're going to run a confidence interval, and that's why we're not going to do that part. So X bar plus or minus Z star standard deviation divided by square root of N. Our standard deviation in this case is 8. Our X bar is 28. Our N was 60. And our confidence level is 0.90. And it says we need to calculate our Z star. We start off by drawing a picture of it. This area right here is 0.90. We're centered on our X bar. So we're centered on 28. We have a lower and an upper. And this is going to be a inverse norm of 28. Oh, excuse me, inverse norm. Remember, this is a Z-score. Our area is 0.90. Our mean is 0, and our standard deviation is 1. Because it's a Z-score, so we're always using 0 and 1. This is a center. And when we do that, second vars, inverse norm, 0.90, 0, 1, make sure it's centered. And we end up getting 1.6448, a plus or minus. And I'm going to just write that in red because I didn't leave myself enough room. Plus or minus 1.6448. All right, so those are my Z-scores. So now I'm going to plug that into everything into my equation. Well, X bar is 28. So 28 plus or minus a Z star of 1.6448. Standard deviation is going to be 8 divided by the square root of 60. So now we're going to calculate our interval. So stat test number 7, which is Z interval. And we have a standard deviation of 8, an X bar of 28, an N of 60, and we need to make our confidence level 0.90. And we end up getting an interval of 26.301 to 29.699. So 26.301 to 29.699. I want to say something about this interval. It does not include 30, so 30 is not a plausible value. So this definitely does not appear to be lasting 30 months. All right, or at least with our confidence interval, we can say that. So we are 90% confident that the true population mean battery life lies within the interval 26.301 to 29.699 months. All right, that concludes this exit ticket. Appreciate you watching. Hope to see you on the next one.